Hello everyone, my name is Ben Eady and I'm the Online Media Manager for ModernAnalyst.com, the premier online community for business analysts. I'd like to welcome you to today's webinar titled Requirement Management Best Practices. Today's featured speaker is Carl Wiegers. The webinar will last approximately 60 minutes, including the Q&A session. I'd like to say thank you to RequirementOne for sponsoring this event and hand it over to Andy Heath from RequirementOne to start us off.
Hi everyone, welcome to our webinar. We hope you're going to find it useful. And so before Carl starts, I would just like to do a short intro to RequirementOne. We offer 5 integrated apps that allow you to maximize the productivity and success of your projects. And the most relevant one to today is the specification app, which allows you to manage all of your requirements. We charge $45 a month for this product for each project, and there is a 0 upfront cost for you on that. The important thing to point out really is RequirementOne fully supports all of Carl's recommendations for the tool capabilities. So putting his recommendations together with our product should allow you to deliver much more successful projects. So at the end of this webinar, we've put together a little offer for you guys where if you sign up for our free trial by the 31st of May, we'll deliver an exclusive training session for you to show you actually how to put Carl's recommendations into practice using RequirementOne. So on that note, I'm going to hand back to Carl. I hope you enjoy the webinar, and I'll catch up with you at the end. Thank you.
Thanks very much. Welcome, everybody. Greetings from Portland, Oregon, where it is, of course, raining. Thank you for joining us today, and I think we'll have a interesting session here that will cover a lot of practical suggestions that I hope you find useful and can begin applying on your own project. While I have this slide up, I invite you to visit my website, processimpact.com, where I have a bunch of things you might find useful. There's a bunch of my magazine articles, templates, and other useful items available for downloading. Click on the goodies button if you want to access those, as well as descriptions of my e-learning courses and various other products I have available. You might also be interested in checking out my latest book shown there on the right called Pearls from Sand, How Small Encounters Lead to Powerful Lessons, somewhat of a departure from my previous technical books. I've spent most of the past 15 years traveling around the universe trying to help people improve the way they deal with product requirements. And that covers a wide range of activities, but pretty much everybody is dealing with the same kinds of challenges and problems and headaches. So what I found is that the techniques and practices that work in one situation are almost always applicable to people in other projects and other organizations with a little bit of thoughtful adaptation. So what I'd like to do today is share with you some specific practices and issues regarding requirements management. And the first problem we have that we have to address anytime we start talking about requirements is simply one of terminology. Some people call this whole requirements discipline requirements engineering. Others call it all requirements management. And so we have this immediate terminology problem that leads to confusion. So I want to spend just a moment here explaining how I think of the various activities that we perform in the course of dealing with requirements on one of our projects. I like to subdivide requirements engineering, which is the term I use for the whole domain, into 2 subdisciplines, requirements development and requirements management. And we can further subdivide requirements development into some categories. Now, the goal of requirements development is to deduce, capture, and agree upon a set of functional requirements and product characteristics that we think will help us achieve our stated business objectives. And this involves 4 major sets of activities, and these are not performed in a simple linear left-to-right sequence. They're highly incremental, highly iterative, and you need a lot of little cycles going back and forth. But the basic activities that we're participating in during requirements development are elicitation. I don't like to talk about gathering requirements because that implies to me that you're out collecting them somewhere, just picking them out of the flower garden or something. And really, I think elicitation is a combination of a collection process with a discovery process and an invention process. So those kinds of things are how we identify the requirements that we think we need to implement. We need to do some analysis, which is a matter of understanding those, representing the requirements in different forms, making sure that we've understood them in an appropriate level of detail, and so forth. We need to document what we've learned in some form that can be communicated to the other stakeholders who need to understand, agree to, and do work based on those requirements. And this is the process of specification. And the fourth activity within requirements development is to make sure that we, in fact, have the right set of requirements. So we need to do some validation to determine that our requirements are correct, of high quality, and will, in fact, satisfy user needs. Now, requirements management really deals with what happens after you have some requirements in hand. And in my view, requirements management begins as soon as you've recorded your first requirement, because you might need to start dealing with changes in that requirement. So we're not going to be talking about requirements development here today. We're going to be talking about requirements management as defined in this fashion. There are several key practices that you typically need to perform at various times in your project to various levels of intensity to do a good job of managing your requirements. So our principal goal here is to agree upon a set of requirements that can be used as the foundation for the development work that follows, and then to keep those requirements accurate and current throughout the project. Each set of requirements that we're agreeing on and managing could represent 100% of the final product, as in a pure waterfall development approach where we get all the requirements first and then begin development. Or that set could represent just a few percent of the ultimate product, like in an incremental development approach as Agile teams use, where each time we're doing an iteration, we're building a small chunk of the product and then we're going to grow it over time. So let me quickly go through the basic practices here that I think can help you achieve these requirements management goals. And in the rest of the presentation, we'll take a look at each of these in some detail. The first thing we need to do is establish a requirements baseline. This is the foundation for the work that we're going to do that follows. And this is the agreement that we forged among the various key stakeholders as to just what it is we're going to be building. Well, change happens. And so we're going to have to realize that our requirements are going to evolve over time. So we have to manage the versions of those requirement documents so that people don't get confused about, what sheet of music we're all supposed to be singing from. Really, the core of requirements management is change, dealing with change, not suppressing change. Sometimes people look at a change control process, and that's a scary phrase because they think that means we can't make changes. We're trying to inhibit changes. And that's completely wrong. Change happens whether you like it or not. So what we need to do is build into our projects and into our culture and to negotiate with our customers so that they understand the need to have a structured process that we can use to anticipate and accommodate change, not to prevent change, but to make sure that changes that come along don't disrupt our project to the point where we can't succeed. An important part of that change control process is to do some impact analysis before we start making commitments so we understand the consequences of agreeing to make a particular change that someone has requested. And I'll be talking about all of these as we go along. We might decide to store, in addition to statements of individual requirements, some attributes that gives us a richer understanding of each of the requirements that we're dealing with. One of those attributes might be status, so that we can track the status of each requirement as it migrates from conception, an idea in someone's head, clear up to the point that it's fully implemented and verified in a piece of working software. We might decide to trace the requirements that we start with into the downstream deliverables that we create because each of those requirements exist. The various pieces of architecture, detailed design, user interface fragments, code, tests, documentation, help screens, anything else we create because a requirement exists, we want to make sure we see how those pieces fit together and that we haven't missed something. So that's what requirements traceability or tracing is all about. Now notice when I talk about requirements documents, it need not necessarily be a traditional word processing document, although in my experience, that's still the form in which the vast majority of projects are recording and managing their requirements. But requirements can, of course, be stored in a variety of forms, including Word documents, spreadsheets, on index cards, in some kind of a database, or in a commercial requirements management tool. So that's another technique that we can use to manage requirements more effectively, is to store the requirements in some kind of a tool where we can then have a lot of capabilities available to do a better job of doing these other kinds of things, of defining baselines and managing versions and changes and tracking status and so forth. But regardless of how you choose to store your requirements, we need to apply this set of practices in order to be able to manage them effectively. So now let's take a look at each of these practices in turn. Let's start with the requirements baseline. The term baseline is a configuration management term. A baseline we can define formally here as being a reviewed, approved, and agreed upon set of requirements that's committed to a specific product release. And that doesn't have to actually be a release that goes out to customers. That could be an internal increment or release. So a baseline represents a snapshot in time, a work product or a set of related work products that can serve as the starting point for changes and serves as the foundation for the subsequent activities performed on the project. Now, kind of related to the idea of the baseline is how do we get one? And in many organizations, this involves some kind of a sign-off or approval process. And I'm sure many of your organizations do this yourselves. But I'm guessing that sometimes the sign-off process doesn't work as well as you'd like, or people really aren't sure just what it means. And I think it's a very good idea to consider carefully what sign-off actually does mean in your organization. In a configuration management sense, it would really be a matter of approving that baseline and saying, yeah, let's go ahead. We're gonna build that. But sometimes sign-off doesn't mean anything. It's just an empty ritual that we go through. Sometimes, if you ask people what they meant with their signature when they're signing off on some kind of document, sometimes it means, well, I was given a document and it had a form on the front with my name typed on it and it had a line above my name. So I signed on that line because otherwise no one will write any code. But I didn't have time to read that. I didn't understand all that. I trusted you guys. You let me down. And those are always fun conversations to have. So I think we want to try to avoid those kinds of things where people just go through the ritual of signing off on something as a hoop we jump through. Instead, let's try to reach some agreement of what it means. And here's my proposal for what signing off or approving a baseline really ought to mean. You know, what people are saying with their signature. It might be something like this. I agree that this document represents our best understanding of the requirements for this project today, and that the system described will satisfy our needs. The second thing is that I agree to make future changes in this baseline through the project's defined change process. And here's the part nobody likes, because I also would say I realize that approved changes might require us to renegotiate the cost, schedule, and resource commitments for this project. Everybody wants change to be free, and the fact is change is never free. And everybody has to understand that, and it doesn't matter whether you like it or not, that's just the way it is. Even the activity of discussing a proposed change and then deciding not to do it is not free. That takes some time. So I think it would be a very good idea for each of you to come up with some kind of a statement in your organization that says, when I'm signing off or whatever other approval ritual or activity you go through, this is exactly what that means. And you might even write that on the sign-off form so people know what they're saying when they execute that signature. Some of my clients have done that, and they really found that it was a helpful thing to do. So whoops, sorry. Excuse me, I hit the wrong key there. Get back to where I was here. My apologies. So when we define a baseline, here's exactly what happens at that point. First of all, this is really the trigger for a formal change control process to begin. In fact, that's really what the baseline means. Before that, we're not trying to manage changes in any structured way because we know we don't have the final set of information for that baseline. We know it's still evolving and iterating. But at the time when we draw that line in the sand, then we need to get serious about managing changes because people are making commitments based on a baseline. They're looking at this body of work defined by the baseline of requirements and saying, let's make some schedule commitments. Let's determine what kind of people I'm going to need to get this done, how much money and other resources I might need in order to meet those schedule commitments. And at that point, things that start changing that body of work, modifications in that baseline, are going to have implications. They're going to threaten possibly the success of your ability to achieve your schedule. So that's why we need to get serious about change. Not to deny change, but to make sure that we make appropriate changes in an effective way so as to minimize the negative impact on the project. So I think the idea of a baseline is a really important aspect. Really, that's the foundation for requirements management. You may have been in a meeting sometime, or maybe somebody said something like this, gee, the customer has just canceled requirement number 27. And you say, wait a minute, requirement number 27, I still see it right there at the top of page 5 of my requirement spec. Now, what version of the spec do you have? Well, I have version 3.1. What version do you have? Wait a minute, I have 3.1 also, but you don't have that requirement in it, and I do have that requirement. Why is my version of 3.1 different from your version 3.1? Now I don't know what to believe. You know, it's possible that you've had a conversation like that, and so what happens is that problems arise anytime the project team members are unknowingly working from different versions of the requirements. And because we know they're going to change, we're going to have to be able to know the version of every requirements document and ideally of every single individual requirement at all times. So what this means is we need to put our requirements under version control. And again, when I say requirements documents, I'm not necessarily talking about just a word processing type document. But whatever form you have them in, you have to be able to deal with changes. And it's often a good idea to be able to keep a history of changes that were made, because sometimes you back out of a change. Sometimes you want to go back to a previous version, either to revert to it or to actually just see what it was for comparison. So this means we need to find ways and use techniques to keep our requirements documentation up to date, so that as changes are made in requirements and new ones are added and other ones go away or are deferred, everybody gets the same information. So everyone in the project needs to be able to have access to the current version of the requirements and not have any confusion. I would hope that on each of your projects, all of the stakeholders could go to their desk and access without any ambiguity the current version of the requirements for what they're working on, and we would all find the same thing. So one way that we help make this possible is we don't just give everybody read-write access to the requirements repository. Only certain people should have update access who are authorized to do that, to really make sure that they have a central point of controlling the changes that are made so they get communicated to people. So how do we do this? Well, automated tools are best. So the best approach is to store the requirements in a database of some kind, again, like a requirements management tool. And they'll give us a lot of aid in keeping track of versions. You know, a lot of these tools will retain a complete history of every change that's been made in a particular requirement. So that's very convenient. And if you're not ready to do that yet, then a better approach, not the best, but better than nothing, is to store your documents in a configuration management system and use check-in and check-out discipline so that people are, you know, at least doing change in a controlled way and in a recorded way. And if you're not even quite able to do that, let's at least define some kind of an unambiguous version identification scheme so that we can uniquely label each of our growing and changing documents over time so everybody knows which one's which. I've seen a lot of different schemes used for labeling documents like this, and I'm sure you have as well. I would suggest avoiding documentation identification schemes that are based on dates. I think that gets confusing, and unless you have a real high-resolution timestamp, you could end up changing a document today, printing it out, changing it again today, and maybe they have the same date on it, but they've gone through a couple of changes there. Or you might you know, print it with the date that it's printed, and maybe it hasn't changed since the last time you printed it, but now they've got different identifiers because you're using the date. So that's not so good. Now, a lot of people use an X.Y scheme for assigning version IDs. And I've seen a variety of techniques here. I was once at a company where they said if the number to the right of the decimal, the Y in the X.Y, if that was odd, that meant it was a draft version. But if it was even, that meant it was a baseline version. My brain doesn't keep binary things like that straight very well, so I don't think those kinds of implicit things are very good. So I've seen a variety of methods there that are kind of confusing for people. And you know, where do you start? You start at 0.9 and go 9.1, 9.2, 9.3, and then 1.0 is baseline. These things are clumsy. So I want to describe to you here a technique that I've used for 16 or 17 years, I guess, since I first learned about it, that for a manual identification scheme works very well. And I've used this scheme with some of the clients I've worked with to develop a series of documents as they evolve over time. So the very first version of the document is called explicitly version 1.0 draft 1. So it's clearly identified as a draft, not a baseline or approved version, and we have a sequence number on it. And there's no arbitrary limit to how many drafts we can go through. The next change would be draft 2, and we can go up as many versions as we want. But at some point, we're going to approve that, and who knows how many cycles that might take. But then it's called version 1.0 approved, and that is a baseline version of that deliverable. But of course, things happen. Maybe we start working on it for the next cycle of iteration or something, and that becomes then version 1.1 draft 1 if it's a relatively minor change, or if it's a major change, version 2.0 draft 1, and the cycle continues. So I find that this scheme has actually worked very well for me, and if you're still in a situation where you're doing things manually, you might consider that approach. Well, let's talk about change control here. This is really the central point of requirements management. And of course, the problem is that uncontrolled changes can cause all kinds of headaches for us. It can lead to rework as one person implements something that has been changed since the last time they got the message and they worked on the old version of it. You can end up with degraded quality as changes are made perhaps in final deliverables like code that are not then reflected in the higher level deliverables like requirements or designs. And it can really be hard to predict when you're going to finish a body of work if it's churning too much. So we want to define, and I think this is the first thing every organization should do for its process development, a requirements change process. And that process should define how we propose changes, who's allowed to do that, who we accept them from, how we review and evaluate those, make decisions to approve or disapprove a particular change request, and then how we incorporate those changes into our deliverables and our project plans. One way we can kind of get a big picture of how this change process works is to define a state transition model for the allowed statuses and change states and the changes that we can go through from one state to another. And I'll show you an example of this in just a moment. Impact analysis, as I mentioned, should be a big part of this, and we'll talk about that soon. And it's, again, a very good idea to support this activity, this process, with a tool. But remember, a tool is not a process. These are two different things. One of the best process changes we put into place when I was working in a large web development group at a big company once was change control to help them manage this enormous backlog of change requests they had. And we developed a process on paper and did that kind of by hand for a few weeks as we worked out the details of the process and as I evaluated commercial tools. And then we bought a tool and configured it to support the process, and that was widely considered by the people in this web development group to be the most effective process change we put in place. I was at a company once and doing a process evaluation, and I asked them if they had a change control process, and they said, yes, we use Tracker, which was one of the commercial tools available at that time. I said, well, let's think about that for a moment. Does everybody know how to use Tracker? Do they all know what the steps are in evaluating a change request? Does this get communicated to everybody? In other words, process kind of questions. And they said, we use Tracker. In other words, they viewed having the tool as basically a substitute for the process. They didn't need no thinking process. The tool would take care of them. And that's really not the best way to do it. Now, I have this philosophy that all change requests must follow the process. I might go walking down the hall and somebody, in fact, I used to do this at Kodak. I'd go walking down the hall and somebody would say, hey, I got an idea for a change in that system you guys are working on. I'd say, okay, tell me about it. And they describe the change. I'd say, okay, that sounds pretty good. When you get back to your office, could you please put that in our change control tool as a request, and we'll take care of it. Now, this is a tool that pretty much everybody knew about. Everybody had access to it. Very, very simple online tool for submitting change requests. And what I found was that about half of those change requests never showed up in the tool. And my feeling was, if this isn't important enough to you to spend a couple of minutes sending it into us through the process that we use to handle these things, then I don't care at all about it. And my philosophy was that I'm not going to do any work based on a proposed change in the requirements or anything else until it's gone through the process so that we can appropriately evaluate it and then approve that and incorporate it into the work we're doing. And I didn't regard this as being a barrier. Perhaps it's a very small barrier. It's a structure. in order to make sure that we can handle changes in a sensible and effective and non-overly disruptive fashion. And I said this before, but I'm going to say it again, that people need to understand that making changes in the requirements very well might require that we renegotiate project commitments. That's just the way it is. So I mentioned this idea of a state transition diagram, and this is really just a bunch of boxes and arrows that we can draw to show the possible statuses that a change request could have at any time, and the possible changes we could have according to our process from one status to another. So this really describes the life cycle of a change request. So here's what one might look like. You can use a traditional state transition diagram like this one, or a UML state chart diagram. These are excellent ways to represent status issues like this. So we begin with a change request which gets submitted. Okay, so that's the first possible status, is that it's come into our radar as existing. Maybe we go through some sort of an evaluation process, after which we can decide to approve that change request if appropriate. If so, then at some point we're going to get the change made, and we ought to verify that that change was made correctly, after which we can close the change request. So that straight path is kind of the happy path of processing a change request, where everything goes in a nice straight line and everybody's happy. But there could be some variations here. It's possible that after the change was made, when you go to verify it, you find that, in fact, the change was not made correctly. So then it should revert to the approved status, and you go through and try to make the change again and get it right until you can move on to verified state. Or there may be certain conditions in which you decide you don't need to verify certain types of changes. And that's your choice, of course, but don't view that as just a way to avoid time-wasting process work, and do that in a thoughtful and considered situation. So there you might bypass, go directly from change made to closed. Or perhaps during the evaluation process it wasn't approved, it was rejected, and that's a terminal state. Or maybe we end up at some point along the way that for some reason that change request gets canceled, and that's another terminal state. So basically all of our change requests should have one of these statuses at any given time. And you might actually find it illuminating, I know I did, to track the distribution of change requests over time. So that showed me how much change activity was taking place and how quickly we were responding to the change requests, how many were in our backlog. Now, you have to be a little careful with something like this, not to try to define too many different statuses at once. I once saw somebody configuring their new change control tool when I was at a client site, and they set up more than 20 statuses for change requests. So make this diagram more than twice as many boxes. And even if they're all plausible statuses, some of them were just transient things that you would change it from A to B and then immediately B to C, and no one's going to use them all. It's just too complicated. So something like I've shown here, I think, gives you a set of statuses that's probably enough in most cases to handle typical changes. So this kind of shows how a typical change control system works. And basically, they all work along this way. You've got some kind of a tool that people can use to submit the change request that gets stored in some sort of a database. So a user can submit maybe a bug report or an enhancement request or a change in requirements. And once it's stored into the tool, that gets emailed off to appropriate people. This is the way we did it in a tool that I actually built myself many, many years ago at Kodak. That email would get sent to the customer representatives who were making decisions for a particular project regarding change requests, and they would be sent to the support staff for that same project so that those people knew what was coming down the pike, as well as a copy going back to the original submitting user. Then over time, the customers and the support people can put their heads together and make decisions to provide feedback and responses and comments on that change request, and each of those gets passed back to the user. So every time you change the status, because perhaps you've been implementing it and so forth, the user gets informed about that. And we also had the ability to generate some reports from this so we could see how many change requests are in our backlog and so forth. So this kind of email communications makes this a useful two-way or three-way communication tool. But remember, the tool is not a substitute for a process and people knowing what information needs to go into a change request and who makes decisions and how that gets evaluated. Also, if you decide to do something like this, buy a tool. Don't build one. There's no need for that. There's a lot of good commercial tools available. So the question does come up, who makes decisions? And in traditional terms, that's called the change control board or the configuration control board. Now, the term board sometimes conjures up an image of time-wasting bureaucratic process overhead. But it doesn't have to be that way. The CCB should be no larger or more formal than it needs to be to ensure that the right people make informed business decisions about which change requests to approve. So typically we do have a diverse group. I mean, it might be one person, on a small project, maybe one person is empowered to make this decision, and that's fine. But in many cases, you'll have a diverse group that represents, various functional areas and stakeholders that are involved with the project, including development and testing and others here. So decide who those people should be in your organization. And I think this group needs to be authorized to make binding decisions. If they can only make recommendations, then that means somebody else is making the decisions and is then functioning as the change control board effectively. So I think it's important to do this so they can make those decisions. Note that the people who are on the CCB are the people who need to participate in making the decisions, not necessarily all the people who need to be informed about the decisions. So this should be a relatively small group that represents the perspectives that need to be represented to make good business decisions here. And I think it's a good idea for any group of people like this that has to collaborate and work together to adopt some kind of rules or process about how they work together. I don't think we do that very much. When we collaborate on projects or activities of any kind, and we certainly do that a lot, I think it's pretty unusual for the people involved to actually sit down and talk about how are we going to work together most effectively. So we all have understandable expectations of each other and realistic expectations. So I think it's a good idea for a group like this to adopt a very simple charter. And if you go to the goodies page at processimpact.com, you'll find that there's a charter for a CCB available, a template there that you can use if you decide to create like a little one-page document along this line, so people know what exactly the CCB does, who they are, and how they work. I also have a change control process available if you want to use that as a starting point. So typically these people are going to have a charter that describes what the purpose of the group is, the scope of their authority. On a great big project, you might have multiple CCBs, some at the project level, one at the program level. How do they meet? What's this decision-making process? Do we vote and the majority rules, or does every decision have to be unanimous? Does a consensus reached? Those are all different processes for making decisions. And how do we communicate our decisions to the people who need to know? So typically these people will get together to consider change requests on some periodic basis. They might ask technical people to go off and do some impact analysis so we understand the implications of each proposed change. Then they make these decisions to accept or reject each change request and then communicate that to the people who need to know. They might also set priorities. Not everything's going to get done right away, and we might allocate certain changes to particular releases. So the change control board is really the central point for managing a lot of these kinds of decisions that have to be made in the course of a project. I mentioned a couple of times the idea of doing some impact analysis. Perhaps you've had an experience like this one. You're walking down the hall at work and someone stops you with a request to make a change in the system you're working on or make a change in a requirement for that system. So you hear the request and it seems sensible to you, so you say, sure, no problem. But then you get back to your office and start thinking about this request. And the more you peel away the layers of the onion, the bigger the onion gets. You realize that this was the exact opposite of what somebody else requested a few days ago, so what are you going to do? We can't do both. Or you realize that this is going to take a lot more work than you initially thought to implement this change. But the problem is you already said, hey, no problem. And you did that hastily before you really understood and thought about the request. So too often we make commitments to requirements changes without having worked through the real implications of impact and cost. So I think that's something we don't want to do. We want to have some sort of impact analysis thought process. And I can give you an example, a real example of where this is important. I was at a client site once where somebody told me about a change request a customer had requested or had submitted, and they came up, the developers came up with an estimate kind of off the top of their head. I think they said it would be like 2-man months. Okay, fine, yeah, let's do that. So they're working on it, and after a while, they realize that they've put in twice as much work, but they're only half done. And so the problem turned out to be like 4 times bigger than anybody thought it was going to be. And they went back to the customer and said, hey, you know, this is a lot bigger than we thought. And then the customer said, oh, well, if I'd known that at the outset, I never would have approved this request at all or submitted it. So forget the whole thing. So that project team threw out several labor months worth of effort on a change request that was withdrawn simply because they hadn't done enough impact analysis to realize just how big this thing was. So we have to make good business decisions. So I have, at the goodies page at processimpact.com, there's an impact analysis checklist and a worksheet that can help you go through this kind of thought process. And a few of the items from the checklists are shown here. One thing you might think about is whether this change request would show any conflict with other existing requirements that might make it nonsensical to implement. Identify the affected components that you're going to have to change. If it's a requirement change you haven't implemented yet, then maybe you just have to restate the sentence in a requirement spec. Very simple. But what if you've already implemented all or part of it? Then you might need to go change some designs, some code, some test components, and so forth. You might have to determine whether this is going to have any impact on your user interface or any database structures or help screens or anything like that that could possibly be associated with that. Now, sometimes people implement a change and then they find that the help screen for a particular dialog box is no longer matching the dialog box itself because they didn't update that help screen to match the modified form. Think about whether there's any other implications of changes here, other systems that could be affected if there's some shared code or libraries or hardware effects. Those can be very expensive to deal with. Think about what work products should be reviewed to make sure we've made changes accordingly. Also identify any plans that should be updated. There are several kinds of plans I think projects should have. They should have an SPMP as a software project management plan. An SCMP is a software configuration management plan. The SQAP is a software quality assurance plan. I think those are all very reasonable plans for any project to create. They could be very simple, short things. Maybe your quality assurance plan is just a couple paragraphs in your project management plan. That's fine, but it's something you should explicitly think about, and making a change in requirements could have some impact on your plans. So maybe start with this checklist and adapt it to fit your situation. Here's some other kinds of questions to think about when you're considering a proposed change. Will that change affect the performance or any other quality attributes? I've seen systems that were supposed to run daily, and they got so overstuffed with functionality that they could no longer complete the run that was supposed to be done daily in 24 hours, like a weather forecasting system, for example, that couldn't do a forecast in 24 hours for the next day. There's not much you can do with that but throw hardware at it. So let's make sure we understand those implications. Is the change even technically feasible? Will it overload any of our computer resources that we have in various environments? Will I have to throw out other work that's been completed if we put this change in effect? Maybe that's not a good business decision. Would it violate any business rules that apply to this project or aspect of our business? And does the change affect any other tasks that are currently in our plans that people need to be notified about so they understand the implications? So you go through a couple of checklists like this and really understand the implications, and then we might want to do a little planning, a little micro project plan for each proposed change to estimate the amount of work involved, not calendar time, but our estimate of actual labor hours of effort for each of the tasks we might have to perform, and then put those into an overall cost for processing the change request. Now you might be thinking, good Lord, this seems like an awful lot of process time and overhead just to deal with a change, and certainly you don't have to do this for every change request. Some of them are trivial and evident, so there's no point in doing any more work than necessary for that. But when you're confronting a significant change request that could have some maybe unobvious or greater than anticipated impact on your project, I think it's a very good idea to spend even a couple of hours doing an analysis like this so you can make sure people really know what the implications are and can make good business decisions. So if you think about all the labor hours that might be involved for the task to be performed, that can fit into a lot of categories. And so I have in the impact analysis materials at the goodies page for processimpact.com, I have a worksheet that lists a lot of these possible activities you might have to perform. You might think about who's going to have to perform those tasks, because if you've got people who are working on them, that means they're not working on something else. Do a little planning to sequence these tasks, identify any predecessor tasks that might have to be completed. You know, we're doing a little baby project plan. Also a very good idea to then think about whether this change would be on the project's critical path. By definition, if a task in this change affects the project's critical path, the project will slip by whatever duration that change activity required. That's kind of a definition of what critical path means. So not all changes are on the critical path and won't necessarily hold up the project, but many of them can. So based on this kind of thinking, then you might come up with some sort of a schedule and cost impact from your estimate of how much effort would go into dealing with a change. So you certainly don't want to spend 2 hours doing an impact analysis for a change request that's only going to take you 1 hour to implement. That's just stupid. But I think you can probably judge what kind of change requests might have a lot of iceberg hiding under the water that is worth looking into before you sail too close to it. Now, I think it's often a good idea to store additional information, attributes, about each functional requirement that go beyond the textual statement of the desired system behavior. So if I think of a specification as being kind of two-dimensional here, I think of the attributes as giving us a third dimension of information behind each of the statements in the specification, so that we have a much richer understanding of each of those. Now, it can be pretty cumbersome to do this in a textual document. The layout gets clumsy, it gets very bulky. Maybe you have a template that you use for all the attributes you have in mind, but if you're not going to supply all of those for every requirement, then you have a lot of white space in your little table, and it just becomes cumbersome to do. But commercial requirements management tools make this easy, and that's one of the real advantages of using a tool like that. So this slide suggests a few of the attributes you might want to store about each requirement. But let me suggest that you don't try to use too many attributes at first. Start with just a few and then add more when you're ready to take full advantage of them. But here are some things that you might find useful to get a richer understanding of each of your requirements. We might want to track its status over time. I'll talk more about that in just a few moments. It's often helpful to know what date we created a particular requirement and its version number, because individual requirements will evolve just as requirements documents can. Who wrote the requirement? Who's responsible for it? Sometimes in a big project, you've got these things allocated to people. It's often helpful to know where the requirement came from or why it's there, the origin or the rationale. If anybody points to a requirement in a specification and says, asks you, why are we doing this? Somebody ought to have a good answer to that question. And that's where the rationale can come into play. This also can help you kind of head off some debates at the past. You get partway down the project and somebody comes back and says, well, wait a minute, we don't need that. There's no reason to do it. I don't know why it's there. Well, maybe there was a good reason, and by having that rationale attribute right there so everybody can see it, we can all answer that question ourselves. You might want to know what subsystem, iteration, release, or build it was allocated to. One of the attributes you definitely want to manage at a very early stage is priority. Somebody asked me once, well, when can you start prioritizing your requirements? Well, you might remember I said you need to start managing your requirements right after you have the first one. And as soon as you have 2 requirements, you can start prioritizing them, because priority is really a relative thing. It's a matter of what things are more important or more urgent to do compared with other things. So priority is something you want to get a handle on very early. And this is especially critical for agile and incremental kinds of projects, because you're always trying to deliver the maximum value in the minimum amount of time, as of course we are in all projects. And so you want to make sure that you implement the most timely and the most customer value requirements generally pretty early on. You might keep track of the risk associated with individual requirements, or how are you going to, how critical each one is. And there's all sorts of things you can keep track of for these. We also then might go back to our status attribute and use this as a way to help track requirement status. Typical project status tracking is often kind of vague. The project manager might ask, hey, Carl, how are you coming on that subsystem? Pretty good, I say. I'm about 90% done. Well, weren't you 90% done a couple of weeks ago, he asks. Yes, I say, but now I'm really 90% done. I think we've all experienced this phenomenon of projects or chunks of work being 90% done for a long time, and that's because we don't have very good visibility into just how big the chunk of work is sometimes, and also just where we are on getting it done. So I think maybe a better way to track project status is to describe what % of the requirements allocated to the product baseline have various statuses. So I think that's one of your basic requirements attributes. Let me show you some possible statuses you might consider that will characterize the life cycle of a proposed requirement. In fact, perhaps it starts out as being proposed. That's the initial status. It means it came into view from some source we recognize as a place we listen to when they ask for something. And then after some consideration, perhaps the status changes to approved. We did some analysis, did some impact assessment, and we allocated the requirement to a particular baseline and planned to implement it at some point. So the status is now approved. At some point, someone's going to do some design, they're going to maybe write some code, test that code, and now they think they've implemented that requirement. We need to then convince ourselves that it was actually implemented correctly, and then once we've done that, we can say that that requirement has been verified. But sometimes we change our minds. A planned requirement gets dropped out of a baseline and the status should be deleted. Now this is another good reason to use a requirements management tool, because if you have an attribute like this set up for each of your requirements, you've probably seen a situation where requirements come and go and come back again. Well, you can just change the status so it drops out of the baseline, but you haven't lost the requirement. And that way, if somebody comes back and says, hey, we want to put that one back in, then you can change the status from deleted back to, say, approved or wherever it ought to be in this life cycle. But sometimes someone had requested a requirement and it was rejected, not approved at the point of analysis. And again, by keeping track of those requirements that were rejected, they're still on our radar in case they come back into scope at some point. That does happen. So once you've collected information about the baseline set of requirements that was allocated to a particular project or release or iteration in this way, I think you can get some real insight into how you're coming along towards completion. So if my manager comes and says, hey, Carl, how are you coming on that subsystem? Instead of saying 90% done, I could say, well, 60% of the requirements are implemented and verified, 15% are implemented but not verified, and the rest are not yet implemented. I think we've got a pretty good understanding of where we're really coming along on that project. And you can even draw a chart like this that shows how that distribution changes over time. So what we find here is that at the end of a body of work, all of the requirements in the baseline should have a status of either verified, meaning we built them and tested them and they're okay, or deleted. We dropped it out and decided not to do it. So that would be the green line and the blue line. Those should add up to 100% at the end of the project. Well, next technique I want to talk about here is requirements traceability. The idea that we can connect each of our functional requirements both backward to some specific origin, like a system requirement or a use case or a business rule, and forward to the design or code elements that implemented them and the tests that validate the requirements. So if you don't know where a requirement came from, you might wonder, why are we even working on it? We want to be able to trace it back. Now, to do requirements traceability, the key element is that each requirement must be uniquely identified. And there are various schemes that you can use to do this, but you want to come up with a unique persistent form. And here I've shown a hierarchical naming scheme like print.confirm copies, which avoids some of the problems that you run into with a hierarchical numbering scheme. So come up with some way to label your requirements. And once we've done that, then we can build a requirements traceability matrix. So to show the connections between requirements and other systems elements. Here, in a very simple case, kind of a tabular form that gives us a roadmap for the components of the system that we can see that a particular requirement called FR, for functional requirement 117, turned into a particular bit of design, turned into some code in a particular source file, and that we wrote a couple of test cases against that. So don't regard this as nuisance documentation to create at the end of the project if you have time. You have to create this as you go along. You start creating it after you write the requirements, and you populate it as development progresses. There are various reasons that you might want to do this. I don't know about you, but I've gotten to the end of a project and just suddenly realized I just forgot to implement a requirement. I just overlooked it. And if you're collecting this information as you go along, that basically can't happen. You can see at a glance what work has been completed, because if you haven't filled in a box, you didn't do the work yet. Suppose test action.3 fails. Well, we know we can go back to the code related to that same functional requirement that's shown in the requirements traceability matrix to start looking for the problem. And also, if there's a change, somebody comes along and says, let's change FR117, then this can help us know exactly what we might have to modify in order to implement that change correctly. Now, the requirements management tools help us a lot with managing these kinds of things, because this is something you can't do by hand on anything other than a very small project. And one of the things you can do in a requirements management tool is kind of see a table form like this that shows which functional requirements might relate back to, say, a particular use case. And you might see a notation like this, a little arrow that indicates that use case number 1 traces down into functional requirements 1, 2, and 4. Use case number 2 traces also into functional requirement number 2, that's reused, as well as FR3. And use case number 3 then traces into functional requirements 5 and 6. So here we can see a map of those logical connections. And if you change an object stored in this database on one end of the link, like UC2, then the next time you see the matrix, there might be some kind of a visual indicator that the objects on the other end of those links need to be changed. And this particular tool that I'm illustrating here uses a diagonal red line to say, hey, you changed UC2, so you better check FR2 and FR3 and see if they need to be changed, because those are all logically linked together. So this is very helpful with keeping track of all the stuff going on in your project. And there's just a table here. You'll be able to see these slides online, so I'm not going to go through this right now. You'll be able to see it at the Modern Analyst website. But this gives you an idea of who might be the right people to provide various kinds of traceability information based on what the link goes from and to. We've talked about documents, but there are some limitations of using requirements documents, even though that's what most people do. It can be clumsy to handle requirements for multiple releases. It's awkward if you have to move a requirement from one baseline to another. How do you indicate that, or do you have to move it from one document to another? It's hard to reuse requirements information that's sprinkled throughout multiple documents. And if you have something that appears in multiple locations, like maybe a higher level business requirement in a vision and scope document, and then some detailed functional requirements and a requirement spec, how do you link those together? It's not easy to do. And it's hard to make sure everybody always has access to the current version of the document. And this is where the requirements management tools come into play. They can help you manage versions and changes, as I've mentioned earlier, so you might be able to retain a version history of every individual requirement and define some set of those as belonging to a particular set of baselines. You can store these requirements attributes, some of which the system might define, like the data requirement was created, and others that you choose to define. And then you can create reports. So a requirement spec might just be a report that shows a particular subset of requirements for the project filtered based on certain attribute values, like those of, say, highest priority, or those allocated to, release number 3. You can define these traceability links that I just mentioned, so you can connect pieces of information in the database to other pieces, and many of these tools will let you build traceability links to information stored in third-party products as well, like change request tools or source code libraries. And this is a really big help for impact analysis. Also, of course, these things help you control access, so you can give permissions for read or only or read-write access to groups or individuals, and all of these tools provide access over the web, which is particularly helpful when you have people working in multiple locations. But I've seen a lot of people evaluate requirements management tools, and quite a few buy them, but I'm not convinced that all these organizations are getting their full value from their investment in the tool. So let me give you some quick recommendations for how to get that maximum benefit. First, don't assume that just because you have requirements going into a tool that you're writing good requirements. In fact, I would learn how to write good requirements first and store them in a tool second. Don't expect a tool to replace a requirements process, just as we don't expect a tool to replace a change control process. There's going to be a culture change that takes place in the organization as we have people getting used to storing information online and making updates and generating reports from that. It's a different way for people to interact with the repository of requirements. don't get carried away creating too many different requirement types or too many attributes, because you're not going to use them all, and it just becomes a waste. Expect to have to spend some time training the tool users in how to use these effectively, and make sure people are responsible for performing certain actions like defining those traceability links, because otherwise they just aren't going to get done. And I've seen some people who used only the rudiments of the tools and didn't take good advantage of all the capabilities and power the tool could provide. So if you keep these ideas in mind, and I talk about this more in a chapter in my More About Software Requirements book, some of these tips I elaborate on those, this I think will help you get the full benefit from whatever investment you make in requirements management tools. So the reason that we emphasize managing requirements effectively is to try to avoid the surprise factor that happens at the end of so many software projects. My experience has been that surprises in software are never good news, and I just don't think we want to have any more surprises than necessary. So I am going to turn this back over to Andy.
Thank you, Carl. I hope everybody found that useful. So now you have the process. Hopefully you're thinking about how you can implement it, and we'd like to play a part in that. So if you can get yourself along to our website, RequirementOne.com, and sign up for a trial before the 31st of May, we'll run this exclusive webinar for you and show you how to implement the process that Carl's outlined today. So taking control of your changes, the attributes on your requirements, version control, requirement statuses, and all that lovely stuff that Carl's talked about. And you can do that all with RequirementOne, and on the left-hand side of the PowerPoint you can see there, that's what our application looks like. So you have all the benefits and usability of a Word document look and feel, but the benefits of a proper database sitting behind it. So I'd like to suggest you go along to RequirementOne, sign up for your trial, and we'll see you in a week or so for that training session. Thank you very much, and I'm going to hand you back to Ben and Carl for the Q&A.
When using a Word-based requirement system, do you recommend tracking requirements status for the whole document or tracking at individual requirements?
I would track the status at the individual requirements level, because you could very easily have, in fact, you will always have certain requirements in that document that are maybe completed, certain that are approved, certain that are verified. So I think it only makes sense to track that at the granularity of individual requirements, or perhaps small groups of requirements, but not at a document level.
Yep. Many changes are defined while, let me see, gotta read this properly, I apologize. Many changes is defined while development by the developer. It's not time for changing. How should we handle it? I'm sorry, that's...
So it sounds like a lot of the change requests were made by the developers. Is that what that's getting at?
Yeah, I think so.
Yeah, well, certainly developers will often have ideas for changes in requirements, and I think that's great. The trap you have to watch out for is a developer who overrides a requirement and doesn't really tell anybody, and then just goes off and implements what they think they ought to implement, or in the way they, or implements some variant of the original requirement, and doesn't communicate that, because now what we have is a disconnect. We might have testers that are expecting to test the original requirement as written in the specification, but that's not what the developer chose to implement, and so you can end up with people saying, hey, this requirement's broken, it failed these tests, and it turns out, well, it wasn't implemented in a way that was going to let it pass those tests. So I think that's the concern. We certainly don't want to stifle creativity and ideas for change from any place, but you also don't want to be implementing changes that haven't gone through some sort of consideration, thought process, approval to make sure that we understand the implications of it, and then communication to everyone who might be affected by that.
Right. Susie has a good point. At what point do you re-baseline?
At what point do you re-baseline? Well, there are different ways to do that. For example, if you are, suppose you're creating a single requirement specification, but you're planning to implement the product in several phases or several iterations, then you might start out by baselining your initial set of requirements for release 1, and then as you add more requirements to that for the next iteration or release, do that in the form of revision marks so that you can see them as being distinct from what was in the original baseline. And then when you think you've got the requirements all in there for what you plan for that next release, re-baseline it. Keep a copy of the original, but re-baseline it so that you can say, all right, now those have all been approved. We don't have to be cluttered up with revision marks. but now we know that this is an approved set, which now covers the next iteration as well. That would be one situation in which you would re-baseline on a release by release or increment by increment basis.
Yeah, that's a very good point here. Okay, so do you see any problems with mixing requirements and issues, bugs in the same tracker?
I know a lot of people do that. In fact, a lot of people get like a bug tracking or issue reporting database, and they use that to handle change requests as well in requirements. There's certainly a lot of commonality, but I think if you looked at the specific pieces of data associated with, say, a requirement change request versus a bug report, I think you'll find that the data is a little bit different. There's probably different pieces of information you need to know about each one. So if you have the ability in your tool to maybe set up different classes of entries so that you can have different attributes assigned so that you get the right information for a change request and the right information for an issue report, that's fine. But otherwise, I think you're going to find it's kind of a force fit, and the the information might not really be all there. But a lot of people do that kind of thing, and certainly that's not an unreasonable way to start, and then get things fancier when you decide you need to.
Yep, that's a very good point. So we'll take two more questions here. First one I got is, sometimes there's confusion between release management and version management. Could you elaborate a little more on that?
Yeah, the version management that I was talking about was really for, evolution of, say, a document over time, where we need to make sure that people can distinguish one circulated version of a document from another circulated. You don't need to do version control on things that are in your own sandbox that other people aren't going to see except for possibly for review. But certainly anything that's going to be distributed or accessible to others, we need to keep versions distinct on those. Release management, may or may not map into the versions of specific documents. It very well might. If you have, say, a requirement spec for, version 1 or release 1 of your product, and then another separate requirement spec for release 2, then, making version changes in the first document would then still correspond to what you plan to release in release 1, and so forth. So if those intentions of what you plan to release are mapped tightly to a specific document or specific version of a document, then release management and version management will be kind of the same thing. But in a lot of cases, that's not going to be the case. You might have a larger requirement spec, all versions of which need to be distinguished from all other versions, but that might encompass the requirements that are planned for multiple iterations, and that's another question entirely then.
Right. Well, we've got time for one more question here. Can you offer any more advice on how to decide when it's easier to just do a small change rather than go through the rigors of a time-consuming impact analysis?
Well, there's a lot of kind of eyeballing of something. The trap is that I would prefer to err on the side of doing impact analysis rather than not, because if someone presents you with a request, and you just glance at it and it seems, no big deal, a couple hours, I can do that. If you have enough experience and you understand the request well enough to make that judgment and are confident in it, fine. But if you're just doing that off your top of your head, that's where you start getting into trouble. That's where we run into this phenomenon of saying, yeah, sure, no problem, and then thinking about it later and realizing, yeah, this is a lot bigger than we thought. So I can't really give you a heuristic because there's an infinite type of range of possible change requests that you might hear. But in your environment, I think the key is to make sure you have enough information from the person who's proposing it so that you can even do a quick mental analysis and say either, yes, that's very easy, no problem, or let me get back to you on that. In other words, that's actually the best answer to almost any request for an estimate is let me get back to you on that, so you can go away and think about it and get the additional information you need, whether that takes 5 minutes or 3 hours, to make sure that you're doing something sensible. So I can't give you sort of a little red flag that jumps up and says, ooh, I need impact analysis, because there's just such a wide range of possibilities. But just be cognizant of that so you don't end up saying yes too hastily.
Thank you, Carl and Andy, for an informative presentation. Thank you, everyone, for attending today's Modern Analyst webinar. I wanted to point out that the webinar, along with slides, will be archived at ModernAnalyst.com within a few days. This concludes today's event, and we hope you have a great day.